Morning, guys. I thought that I would just show my face on here, in case you have forgotten how I look. I am going to show you guys quite a lot of stuff from the answer series book. All right, so that will be the first section. We're just going to page through some of these. I will put it up on the screen now, and then we're going to do some examples. All right, let me just start the screen sharing here. There we go. Sphere 2 share. Okay, there we go. Let me change. Oh, sorry, I muted that by accident. Let me just use the Ava Vision, and then for the video, I also just want to use the camera. There we go. Okay, so we are starting with exponential graphs. We'll zoom in a bit here. I'm actually not going to draw all of these like short examples because it will take very long, and I don't actually think it's necessary. You guys are going to get a copy of this book when you get back to school, so I think we can just refer back. So in the note, we are going to do a note. I will just write next to the heading, see pages 151 to 153. So let me actually add that straight away. See page 151 to 153. All right, for all of these small notes that we're going to be making, or these small graphs that we're going to be looking at. So in core maths, we have drawn graphs of exponential functions. We now are going to focus on exponential graphs where the base is e. Let's remember that e is a number, right? E is 2.718, blah, blah, blah. So if you have a graph of y equals e to the x, you're going to do the same thing as when you have to draw the graph of y equals 2 to the x. Okay, because e is also just a number, just like 2. So I don't want you guys to panic about this. All right, there are some properties here of the graph y equals e to the x. You can see that they have drawn the example here. Our y-intercept is 1, because if you remember for your y-intercept, you have to make x equal to 0. So that will give you y equals e to the 0, and anything to the 0 is just 1. Okay, they've written it there. So the y-intercept is 1. You don't have a q value there. Remember that the standard form of exponential graphs is y a times b to the x minus p plus q. And q is always your horizontal asymptote. All right, so now, if there's no q value written there, then our horizontal asymptote is actually just going to be y equals 0. So, which is the x-axis. Okay, so in this case, the x-axis is the y, or the horizontal asymptote. My apologies. All right. Now, usually for an exponential graph, we would try and find an x-intercept as well, but since the x-axis is an asymptote here, if you try and find an x-intercept, we're not going to get anything, okay, because the x-axis is an asymptote, so the graph can't touch it, so we don't have an x-intercept. So we would sub in -1 and 1. If we sub in 1 into this equation, we're going to get y equals e to the 1, which is just e, so you can see that point there. Now, guys, remember that e is 2,72, we can say, right? And do we see that that is actually kind of there, 2,72? Right, so that's fine, that's straightforward. If we had subbed in the value -1, they didn't show it on this graph, but then we would get e to the -1, which is 1 over e, which is 1 over 2,71, blah, blah, blah. So that would give you that value over there. All right, across from -1. So you could do that as well. The domain here will be x element of real numbers, and the range will be all real numbers for y greater than 0. Okay, it's also written there. Now the derivative and the integral, we're not going to discuss that now because we are going to still speak about that at length when we actually do derivatives and integrals later on. So I'm not going to stress about that now, but that is what the graph looks like. It's just like any other exponential graph. Okay, now when we're doing exponential graphs, it is quite useful to think of how the basic graph of y equals e to the x has been transformed, either reflected, translated, and so on, to give us the new graph. All right, we know that the A value will stretch, will make the graph steeper or less steep. The P value will move the graph to the left and the right, and the Q value, which is the horizontal asymptote, will move the graph up and down. So that's what I mean when I say transformations. All right, we also have reflection. So if we see the graph y equals e to the negative x, do we see that the x value has changed its sign? And that is what happens when you reflect something about the y-axis. So here they have the original graph of y equals e to the x, and now they've just flipped that graph over the y-axis, all right, and they get the graph of y equals e to the negative x. So the point 1e now becomes the point negative 1 and e. All right, this point, negative 1 and 1 over e, becomes the point positive 1 and 1 over e. All right, because the x value is changing its sign, so all the x values of all the points will also just change their signs. Okay. If we reflect about the x-axis, remember when you reflect about the x-axis, then the y value changes. So we would say negative y equals e to the x, but then we would have to take that minus over. So that's why we get y equals negative e to the x. And we can see this graph has now just flipped over the x-axis. All the y values now become negative. All right. And about y equals x, hopefully you guys remember from last year in AP that whenever you reflect a line or any graph actually, about the line y equals x, you get the inverse of that function, of that graph. Okay, so that is what's happening here. Remember when we do the inverse, I did give you guys a note last year, which is on the classwork section of the Google Classroom page. So when you do the inverse, the x and the y values swap around. So the point 1e becomes e1. The point 0,1 becomes 1, 0. And the point negative 1, 1 over e will become 1 over e negative 1. Okay, and please note, guys, the equation of this. Remember, if we have y equals e to the x, all right, that is the original one, y equals e to the x. We are still going to talk about this at length, about inverses later on, all right, at the beginning of next week, so don't panic about this now. I just want to show you. If we do the inverse, we have to swap x and y. So this will be the inverse, but now we can't leave it like that. We need to write it so that y comes first. So in order to do that, in order to make the exponent the subject, we need to write it in log form. So y equals, the base of the exponent will become the base of the log. And what is log with the base of e? Ln, and then x. All right, so this is something you can actually memorize. The inverse of y equals e to the x will always be y equals ln x. Okay, but again, we're going to talk about that at length later on. Okay, I just wanted to show you guys quickly where that equation comes from. All right, now we get to translations. So firstly, vertical, this is what we discussed with the q value. All right, so the q value is your horizontal asymptote, or y equals q, rather, is the horizontal asymptote. If q is positive, then there is a vertical translation upwards. All right, if q is negative, there's a vertical translation downwards. I'm sure that makes sense to you guys. You can see here we have the original graph, y equals e to the x. Here we have y equals e to the x plus 1. There you can see that asymptote is there. And the entire graph has just shifted 1 unit up. Here we have y equals e to the x minus 1. So this whole graph has shifted 1 unit down, and there we have our horizontal asymptote at y equals negative 1. Okay, horizontal shift. This is now where that p value comes into play. So now if p is positive, so if you have something like y equals e to the x minus 1, then we're moving 1 to the right. Remember, this sign in the equation is opposite to the actual direction of the shift. All right, we spoke about that last year. So here we have the original graph. Here we have the graph of e to the x minus 1. We can see that it's shifted 1 unit to the right. So the point 1e now becomes 2e. The point 0,1 will now become 1, 1. All right, and then similarly, if p is negative, so if we have e to the x minus negative 1, that will give us x plus 1, right? Then our whole graph is shifting 1 unit to the left. So there, the point 1e becomes the point 0e. Okay. Now we just have our vertical stretch or compression, which is what happens when you have an A value that is different from 1. So if your A value is bigger than 1, so if we have, for example, here we have y equals e to the x, and here we have y equals 2e to the x, all right, that actually makes your graph steeper, because all of the y values are now being multiplied by 2. So all of the y values of these points, right, will now be multiplied by 2. So they will all actually be bigger. That is why that happens. That's why the graph is steeper. If you have an a value that is between 0 and 1, so that's a fraction, for example, here they've used 1 over 3. Remember, e to the x over 3 is the same as a third e to the x. Then each of these y values of these points, these ones, they're here. Each of these y values are now being multiplied by a third, so they're smaller, which means that this graph is flatter, all right, less steep. So that's how that works. Now, when we're doing combinations, which is what we will be doing most of the time, and what they mean by that is where you have a stretch and a compression plus a vertical shift plus a horizontal shift, right? Or maybe only 2 of those. You might get all 3, which is what we're actually going to have in this example. We need to indicate the following, and I did write it in the note, so we're going to go over to that note now, actually. So this is the note that I have started preparing already. There we go, drawing exponential graphs. So there we have see page 151 to 153 for that summary. So these are the things that we need to keep in mind when we're going to actually draw these graphs. Okay, and we need to actually show these things. We need to label these things. So let me add that there. Label. All right, that is what you're going to be getting marks for. So it's very important that you do that. We need to show our horizontal asymptote. If it is not the x-axis, if it's the x-axis, we're not going to have to label that as a separate thing. Okay, the x-axis is already there. We need to show any and all intercepts with the axes. So we're going to have to calculate that. We're probably going to have to show one extra point by subbing in an x value. Okay, that's so that we can get an accurate shape. So it's useful if you have your y-intercept, you have a point on the left-hand side, and you have a point on the right-hand side. Okay, so we are going to have to sub in either a positive or a negative, or maybe both x values to get an accurate shape. And then this is something new, which we're going to look at today. In AP, the focus is not so much on the calculations all the time. It's actually often more on the concept. All right, so if we want you guys to draw an exponential graph, we don't want to, within that, necessarily penalize you for solving an exponential equation. You can actually use the solve function on the solver calculator. So I'm going to show you that today. I'm a bit rusty on that, but we'll see if we can sort it out. Okay, and the solve function is actually a very nice way of right away getting your answers for x. Okay, so let's see. We're going to do this one. Draw a sketch graph of y equals 2e to the x plus 1 minus 1. Right, now before we even start, I just want us to write down what these shifts actually are going to be. So this is going to be 1 down. All right, so straight away we can actually write that our horizontal asymptote is going to be y equals negative 1. Okay, that is the first thing that we can write down straight away. This plus 1 is going to shift the graph 1 to the left. Remember, the sign in the equation is opposite to the sign of the actual shift, or the direction of the shift. All right, so if it's x plus 1, it's going to move 1 to the left. And this 2 is going to make the graph steeper. It's not really that important that you actually are writing that down. It's just, since we've just discussed the transformations, I just wanted to tie that into this. Okay, horizontal asymptote is y equals negative 1. That's also the first thing that we're going to draw in. All right, next thing, we need to find our y-intercept. And remember, for that, we let x equal to 0. Okay, you don't have to write that down, but that is what we're going to do. So we're going to say y equals 2e to the 0 plus 1 minus 1. So basically 2e minus 1. And now, guys, we're going to use our calculator, all right, just to give us a bit of an idea of where that actually is, because 2e minus 1, I mean, what does that even mean? All right, so we're going to say, shift or 2, and then alpha, and our e button, there we go, minus 1, and that is going to be 4,44, basically. Right, so that is our y-intercept. You can see that that is much bigger than the usual y-intercept. The y-intercept of the straightforward graph y equals e to the x would be at 1. Now the y-intercept is at 4,44. So we can already see that this graph is going to be steeper, right? Because on the one side it's going to go up from 4,44 as well. So that's just something to keep in mind. So our y-intercept here, I see that this has smudged now, but it's fine. The y-intercept is 0 and then 4,44. There we go. Okay, now, since our horizontal asymptote is y equals -1, the graph is going to move down, so it will have an x-intercept. All right, so that's important to recognize. So we need to do an x-intercept calculation. Now for this, we're going to have to make y equal to 0. So let y equal 0. So we're going to say 2e to the x plus 1 minus 1 is equal to 0. All right, now here we could obviously just solve this normally. Let's quickly do that. So we would say 2e to the x plus 1 is equal to 1. And then e to the x plus 1 is equal to a half. All right, now in order to solve for the exponent, the variable in the exponent, we need to write this in log form. So we're going to say, therefore, the exponent becomes the subject, and the base of the exponent becomes the base of the log. So log base e is ln, and then a half. So x is going to be ln of a half minus 1, which is ln 1 over 2, close bracket please, minus 1 equals -1,69. Okay, so that is the x-intercept that we have here. Now guys, please notice that this is a negative x point. All right, so we have our y-intercept. In the middle, we have our negative x value, so we need a positive x value. So I'm going to sub in x equals 1. So that is now for the 1 extra point. All right, so let's sub in x equals 1. So we're going to have, and you don't actually have to show the substitution. I'm just doing it for the sake of the example. So x is then equal to 1. So we have 2e to the 1 plus 1 minus 1. And this is then, let's work that out. Now, because we're going to have e squared, we need to use this other e button, all right, the one that has the block. So e squared minus 1, and that is 13,78. All right, so we have the point 1 and 13,78. Okay, I just want to pause here quickly. Someone just walked in. Just hold on for a second. Okay, I'm back. Sorry about that. So now, before we draw the graph, I just want to show you quickly how to solve this using the solve button on the calculator. All right. We are going to use it quite a lot later on in the year as well. So if you are not 100% sure of how to do it, I'm sure you can find a video on YouTube that shows you as well if you don't like me just showing you in one example. But we can also look at it again in class. So what you're going to do is you're going to type this equation out. All right, so you're going to type 2 and then e to the x plus 1. Plus 1 minus 1. Now, instead of saying equals, you're going to, do you see there above the calculation button, it says solve, right? You're going to say shift and then solve, and there it shows you solve for x. All right, but now what I did beforehand is I made it equal to 0. It's not showing that now. If it's the first time that you're using this function on the calculator, it will say solve for x, and then there will be a number there. All right, so you can then put in 0 and then press equals. I'm not sure how to clear this now. We can check again in class. All right, an alternative option, I think, is to type it in. I think. Sorry, I don't use this function a lot. But like I said, we can figure it out in class. So here you can have 2e to the x plus 1 minus 1. And then that same button, the solve button, has an equals there in the pink color. So if you say alpha and then that, it will give you equals and then 0. And then I think, oh, syntax error. Let's check. If we say solve now, oh, there we go. There it will solve for x. Okay, sorry, that was not fantastic. I'm going to do it again. 2e to the x plus 1 minus 1. Then you do alpha and the solve button for your equals and then 0. Then instead of pressing the normal equal button here at the bottom, okay, we're not going to press that. We now want the calculator to solve this equation. So we're going to say shift and solve. And there it will solve for x. Right. So that's great. I mean, I think that's a wonderful thing that you can do. And you can use that in all AP questions from now on, unless the question says showing all steps or without the use of calculator, you know, that kind of thing. So that's very useful. There we get our negative 1,69. Okay. Now we obviously need to draw this graph. So I've already set up my axes. My bottom y-axis is a bit longer than it is necessary to be. But anyway, let's do it. Okay, we're going to do our y asymptote, a horizontal asymptote at y equals negative 1. There we go, y equals negative 1. Now we're just going to plot our various points. So our x-intercept is at negative 1,69. So let's say that's kind of there. Right, this is just a sketch graph, so it doesn't have to be 100% accurate. I'm not going to measure it or anything. Our y-intercept is, so these are 2. Oh, flip, yeah, I forgot. Wait, this is 1. Okay, sorry. I've used a scale of 2 on the y-axis because we need to go up to like 14. All right, so each of these notches actually represents 2 units. So 4 is going to be there, and then kind of 4 will be kind of, like over there. All right, and then the next one, 13,78. So 2, 4, 6, 8, 10, 12. There's 14, so 13,78. Oh, sorry, I'm putting it in the wrong place. Is kind of over there, I'm guessing. Yo, what a very unfun graph to draw. I'm thinking now, actually, I want to change my, I think, yeah, I want to make each of these, I made it 1 unit. I'm actually going to use it like this. Again, guys, a very nice advert for these friction pens. I'm actually changing my scale on my x-axis just to make this graph a bit easier to draw. All right, so this is now going to be 1. So I just need to remove that point there. Right, and let me just fill that line in there. There we go. So if this is negative 1 and that is negative 2, then negative 1,69, that's negative 1,5 will be just short of that. Yeah, just about there, I think. Okay, that will be easier to draw. Obviously, the scale is not the same on the x and the y axes, but I'm just doing it so that it's easier to draw. And then this is actually 1, and it's going to be over there, like that. Not that point there. Let's just fix that one, take it away. Okay, and now I'm just going to pause again quickly so that I can draw this in. I'm going to have to turn my, what's it called, my book around. Okay, there we go. So I've just joined these points. Remember that it's supposed to be a curve, so you're not allowed to use a ruler. And then we need to label all of those things. All right, so all of those points you have to label properly, and you have to obviously label your horizontal asymptote that we did in the beginning. Okay, so guys, I actually don't think this is too hectic. It's just getting used to the fact that E is a number. And yeah, apart from that, it's not really anything new. Okay. For the next lesson, we are going to work with absolute value in exponential graphs. So I am going to record that tomorrow morning when I get to school, and I'll post it. It is a bit more tricky, obviously, but yeah, I want you to practice drawing some of these before you try the absolute value ones. Okay, these ones are obviously easier. So I'm going to give you exercise 14.5. From this answer series book. So on page, it is on page 154. And I want you guys to do number 1. All right, now there are lots and lots of graphs in number 1. So maybe let's not do all of them. Let's do D to H. Right, number 1, D to H. You are obviously more than welcome to do all of them if you feel like you need the practice. But then the ones that they are asking in number 2 are the absolute value ones, all right, which I want to keep for the next lesson. After that, we need to look at log graphs, which are the inverses of these exponential graphs. And then from there, we are going to look at inverses. Let me just double check quickly. Log graphs, yes, we'll draw 1 or 2 of those, and then we'll look at inverses. And then we're actually done with this chapter. Okay, with working with E and Lin. It is going to come up again later on when we look at derivatives and integrals and so on. Okay, but tomorrow is going to be the absolute values, and then next week on Tuesday and Thursday, we will, I will decide. Oh, you guys are all here every day. Sorry, I was still in the group 1, group 2 thing. Yeah, next week, Tuesday, Thursday, we will do the log graphs, and hopefully we'll be able to fit in the inverses as well. And then the following week, we can start with derivatives. Okay, so we've actually done really well. I want to congratulate you guys. I want to thank you guys for being so willing to do work while you're still kind of on holiday. I really appreciate it. It's definitely taken a lot of pressure off of me in terms of getting through all the work, and hopefully you guys will also feel that there will be a little bit less pressure on you. I am thinking about going forward, maybe giving you guys a video lesson to do on your own every second weekend or so, just so that, again, we're not so rushed during class time. We actually have time to spend on more questions and more exercises than we would have before. So you can just think about that, whether you think that would work or not. But yeah, thank you. And thank you also for being so understanding every time I had to change things up. I really appreciate you guys being so understanding and, yeah, hopefully not holding it against me. All right, do these graphs, please, and then we will chat again tomorrow. Thank you.